There's a huge difference between a quick script you throw together and a real production-grade web scraper. So today, we're going to pull back the curtain on the Go WordPress project. It's a pretty sophisticated scraper written in Go, and we're going to deconstruct it piece by piece to really understand what makes a scraper fast, tough, and easy to manage in the wild.
All right, so here's our game plan. First, we'll talk about the big challenges of scraping and why simple scripts just don't cut it. Then we'll look at the smart architecture this project uses. After that, we'll follow the data on its journey, see how it gets cleaned up, and finally, wrap up with the features that make this thing truly ready for prime time. Look, anyone can write a few lines of code to grab a headline from a web page. That's the easy part. But building something that works reliably, day in and day out, against websites that are constantly changing, well, that's a whole other beast. That's a real engineering challenge. And this is the big question, isn't it? This is what it all comes down to. You're trying to balance being fast with being polite to the server, all while making sure your system is reliable. The Go WordPress project was built from the ground up to solve this exact problem. The difference is really night and day. On one side, you have your brittle scraper. Think of it like a house of cards. It's hard-coded, it's slow, and the second a website changes a tiny little thing, the whole thing comes crashing down. But a production-grade scraper? That's built more like a fortress. It's configurable, it's fast, and it's made of resilient, testable parts. It's a huge leap from just a script to a serious piece of software. So how do you even begin to build something like that? Well, it all starts with a solid foundation. The Go WordPress project is built on this really clean, modular architecture that makes the whole system so much easier to manage and to scale up. At the heart of this architecture is a powerful pattern called dependency injection, and in this project, it's handled by Uber's FX framework. The best way to think about it is like a professional chef's kitchen. The chef doesn't stop cooking to go forge their own knives, right? No. All the tools, the knives, the pans, the database connection, the logger, are all laid out and provided for them. That's what the framework does here. And the payoff for this approach is huge. Your components aren't all tangled up like spaghetti, which makes testing them an absolute breeze. The framework also handles the boring but super critical stuff like starting everything up and shutting it down gracefully. And you can see how the entire system fits together just by looking in one central spot. It's clean. Okay, now for the really fun part. Let's see how this system actually goes out and gets the data. We're going to follow it down the assembly line, from the moment it discovers what to scrape, all the way to processing. So, it all starts with a bit of intelligence. Instead of just being given a list of pages, the system is smart. It crawls a website's main navigation to automatically find all the product category links, and is clever enough to ignore stuff you don't want, like login or admin pages. Now, once it has that list of categories, a simple scraper would do things the slow way. It would ask for a page, wait, process it, then ask for the next page, wait, process it. It's safe, sure, but it's incredibly slow. But Go WordPress is much smarter than that. It uses concurrency. It makes multiple requests at the exact same time, which just dramatically speeds up the whole process of gathering all those product listings. And this is where the implementation gets really clever. It doesn't just go wild and send 1,000 requests. It's configured to run exactly 4 concurrent requests at a time, with a half-second delay between them. And that number isn't random. It's the sweet spot, fast enough to be efficient, but polite enough that it doesn't hammer the website's server and get itself blocked. Now this right here, this is a total game changer for maintenance. A brittle scraper would have code that says, find the H2 tag with the class product title. But here, all those instructions, the CSS selectors, are pulled from an external config file. So if the website changes its design, you don't have to recompile your app. You just update a text file. That's huge. All right, next up, fetching the detailed descriptions for every single product. Now, we're talking about potentially thousands of pages. Firing off all those requests at once would be a complete disaster. So the system switches gears and moves to a batch processing strategy. It pulls this off using something called the semaphore pattern. And honestly, the best analogy is a bouncer at a club. The bouncer only lets a few people in at a time, right? In this case, it lets exactly 4 requests run at once. As soon as one is done, another one gets to go in. It processes products in these small controlled batches, making sure it never, ever overwhelms the server. So now we've got all this raw data. We're done, right? Ha, not even close. Raw data scraped from the web is messy, it's inconsistent, and a lot of the time it's totally unusable in its raw form. This is where the project's data cleaning pipeline really shines. This just captures the problem perfectly. The scraper finds a price, and it looks like this: a string with commas, a currency name, and even non-standard digits. To a database, that's just garbage. The whole point of the cleaning pipeline is to turn that mess on the left into that beautiful, clean integer on the right, something you can actually use. So how does it work, that magic? Well, it's a very precise, multi-step process. First, it chops off the currency label. Then it strips out all the commas. Next, it gets rid of any other random characters that aren't numbers. And for the final touch, it even converts Persian digits into standard ASCII digits. The result? Perfectly clean, normalized data every time. Okay, last but definitely not least, let's look at the features that take this project from just a clever script and turn it into a true production-ready application you can actually depend on. This is what real-world toughness looks like. Rate limiting makes it a good neighbor on the web. Timeouts make sure one slow request doesn't stall the entire system. And my favorite, graceful degradation. If scraping one category fails, it just logs the error and moves on, instead of the whole program crashing and burning. And mutex protection, that's just a fancy way of saying it's like a traffic cop for your data, making sure concurrent processes don't write over each other and create a mess. This thing is built to survive. And, of course, none of this would be trustworthy without a solid safety net of tests. The project has a whole suite of them that validate the entire process, from basic crawling all the way to making sure special characters in other languages, like Persian, are handled perfectly from start to finish. And that really brings us to the core takeaway here. See, it's pretty easy to build something that works on a good day when everything goes right. But the principles we saw in this project, modularity, graceful failure, configurability, and testability, that's what makes the system truly resilient. So the question to ask about your own work is it just working, or is it truly built to last?